joining us bright and early this morning. I'm Jonah. I'm representing our cubes.
I'm Carter. I'm representing Lake Effect Engineering and Management.
I'm Sean. I'm representing SAAD Engineering Group.
I'm Justin. I'm representing DGN Associates.
And today we're going to present to you the work that we completed this semester for this project.
All right, so our project is located in Ashland County, Wisconsin, and it concerns 4 sites along the 11 miles of railroad known as the Ashland subdivision. So this line, the history of this line dates all the way back to 1871 when the Wisconsin State Legislature chartered the Wisconsin Central Railway. And the line opened the traffic in 1877. 1909, the Sioux Line took over. In 1987, another Wisconsin Central took over. And then in 2001, CN took over the Wisconsin Central, more so for the Wisconsin Central's line between CN's Canadian Main and Chicago, and for Chicago to Minneapolis. The Ashland subdivision was also part of that sale. And then in late 2021, WACO purchased the Ashland subdivision along with a few other rail lines in northern Wisconsin and the UP from CN. So a little bit about our client WACO. They own and operate over 50 railroads in 27 states, Canada and Australia. And a couple other services that they do are materials handling, logistics, repair and maintenance, and design and development.
So this is what caused all the issues that we solved problems for. In July of 2016, the region of Ashland, Wisconsin experienced the highest flood, or the most intense flood ever recorded. And you can see here on the left is a rainfall chart, and the lighter color indicates a higher rainfall. So that storm just swept through, and a lot of rain in a short amount of time. These are hydrographs of the 4 springs within the general area. With their baseline flows, you can see as soon as the rain hit, all of them spiked up super high, and just a gigantic rush of water and washed out various structures.
So why are we doing this work now versus in 2016? Well, in 2016, when CN owned it, CN's a large railroad, they're a class 1. It was seen as the Ashland subdivision was seen as a non-core asset to them. CN is primarily focused on moving large volumes a long distance. That's the most profitable type of traffic for them. After the flood, they determined that repairs would be too costly to justify reopening it with the low amount of traffic that goes over that line. And WACO operates smaller railroads known as short lines, which are primarily concerned with developing that lower volume traffic. Short lines are also eligible for grants to help with projects such as this that class 1s are not eligible for.
So our task for this project were to determine the magnitude of the flood that hit, and to repair 2 bridges that had rail lines running over top of them, an embankment that washed out to repair it, and to design a transload yard in the area. So we have 2 bridges, 1 embankment, and 1 transload yard, 4 sites in total.
So a little bit about the construction schedule phasing. There are 4 construction phases for this project. The first construction phase has to deal with the core construction for the transload yard, including getting the track established so train activity can begin on the transload area. Construction phase 2 has to deal with Bridge 419, Bridge 421, and the core embankment construction. Construction phase 3 has to deal with the long-term stability construction for the embankment, and then construction phase 4 has to deal with the storage building at the transload yard.
So hello again, I'm Jonah, and
I'm Annabelle Needham. I'm Margaret.
I'm Edu.
and we represent R Cubed. Our company was focused on environmental permitting, resources, and anything of that relation.
So the flood that occurred on July 12th, 2016 had a peak stream flow of 40,000 cubic feet per second. Our cubes use a Gumbel probability distribution to determine the year of magnitude of this flood. And this determined that the flood was a 2,400 year storm event with a percent chance of 0.042% chance each year of this event or one greater of it happening each year.
So to give a brief overview of each of the sites, starting with Bridge 421, the name comes from the station number, and it runs across Brunsweiler River. Bridge 421 is the foremost bridge. The back bridge is a travel bridge that goes over Ensinger Road that was not involved in this project. So for Bridge 421, at first, the assumed overflow from the flood event was seen as the source of the washout. We later determined that runoff erosion was the most probable cause, coming from both sides and washing out the soil at the edges of the rail line. Knowing this, we aided the structural design using riprap in their analysis and design.
All right, so this leads us to site number 2. This highway is located right by the bridge and it's the source of the bridge's washout. So this is kind of highlighting how the bridge washed out. Originally, across underneath the highway, there was this culvert that was built, and when the flood hit, the water built up behind the culvert and the culvert couldn't handle it. Culvert failed, highway washed out, and it had a flood-like effect. So the next bridge that we're going to show you is located down here. And as you can see, the water built up, highway failed, and water rushed through. That was the end result. That whole area used to be full of fill, but that fill completely washed out. And then CN came and took out the rail that was exposed. So when we went for our site visit, we saw half a bridge. And from this, because that buildup of water washing it out was more than the 2,400 year event, the current cross section can handle a lot more than a 2,400 year event. So for preventing against future flood damage, we determined that rip-wrapping the sides of the cross section to prevent against erosion was the best way to prevent future washout. And site number 3, this embankment. You can visualize it. There used to be a rail line running right over the top. And when the flood hit, the soil at the top saturated and sheared off the side. So to prevent against future flood damage, the best way that we determined would be to stabilize the soil and prevent against erosion, since the stream that ran underneath it did not rise up high enough to wash out.
This is the transload yard. The transload yard is our 4th project site and it is located in Wisconsin. The transload yard didn't experience any flooding in 2016. But flood stages done by inundation maps from FEMA show that some flooding could occur near the rail lines, and if flooding was to occur, there would be some electrical concerns with this site due to the power lines and other buildings that are on the site. And this is our area of interest. This occurs in Ashland County, Wisconsin, within Ashland County, Wisconsin, there's a Hucktown watershed highlighted in a red circle. And this map on the right shows that Hucktown watershed with each project site and their respective rivers. So the Bridge 421 runs on Brunsweiler River, Bridge 419 is on the Trout Brook. Silver Creek runs through the High Bridge embankment, and just outside of the watershed is the transload yard. So the first design storm. So design storm analysis utilized rainfall data from Ashland County on July 11th. There was 7 hours of rainfall observed with over 4 inches of rain. And we used Snyder's method to create our first design storm, which calculated a peak stream flow of 26,500 cubic feet per second for the entire watershed. So a little bit more about Snyder's method. This uses the watershed area, main channel length, and from the outlet of the watershed to the centroid to create a triangular unit hydrograph. And then from this unit hydrograph, a synthetic hydrograph is created using the lagging procedure to incorporate this rainfall data. And it creates a much larger design storm that is more representative of the actual.
So this is some data from ArcGIS that we used in our next analysis, but this is the land cover land use that we found for the area of interest. The majority of the area is forest at about 67%, and we use this to calculate a runoff coefficient for the next analysis. This next analysis being the rational method, we did both the Snyder's method and the rational method to check to make sure our peak flows were similar. And we use this method and the runoff coefficient was calculated from the land use. The rainfall intensity was obtained from Ashland's rainfall IDF curve intensity graphs. And the design storm used a 1,000-year event for a duration of 6 hours. We use this method because it was easier to obtain specific site information. So calculated for each site, we have a maximum flow rate of Brunsweiler River of 6,400, Trout Brook of 2,000, and Silver Creek at 1,700. So we have these maximum flow rates. That doesn't really give us a whole lot, so we have to calculate height. To do this, we use Manning's equation, which doesn't explicitly solve for height, but through the area, wetted perimeter, and radius, solve for Manning's height. And on the slide, we estimated Manning's N to be 0.04 based on the conditions we saw at each of the sites. And then in the center, we matched the flow rate calculated from the rational method and iteratively solved for the Manning's height at each site. This gave us a height of 9 feet at bridge 421, 5 feet at 419, and 11 at the culvert that runs through the embankment. All of these are not expected to overflow at any of the sites, and mainly the runoff is the issue at each site. So in conclusion, each site brought some unique challenges. Flood most likely didn't overtop the bridges, but it was mainly the runoff and erosion prevention that was a key design aspect. We gave this information to our design teams, and also to conclude, survey would be required for more accurate predictions.
Any questions from the audience?
What does IDF stand for?
IDF stands for rainfall intensity I forget what the S stands for.
Intensity duration.
Intensity duration frequency. That's what it is.
Thank you. Are any of the bridges going to be in danger? Are any of these locations going to be in danger in any foreseeable future flood?
So for the flood event, we don't expect that the bridges would be overtopped. Like we said, our main control was erosion prevention. So that way we have a riprap design that will be further explained to prevent erosion.
Questions from anybody else? Thank you.
Good morning, everyone. I'm Sean. I'm Donovan.
I'm Adam.
Allison.
And we represent SAAD Engineering Group. We have done the structural design and consultation for both bridges on this project.
Hi, I'm Carter again,
I'm Scott.
and we are with Lake Effect Engineering and Management. We did the construction management work for this project, so we'll be talking about the estimate and the schedule for these bridges.
And from us in SAAD Engineering, we will present introductions, the summary of our preliminary designs of both bridges, and go over the structural analyses that we have conducted on these bridges. And a quick disclaimer, all of the structural analysis that we have done is elementary structural analysis from undergraduate students.
The review of Bridge 421, again, Bridge 421 is the northernmost point of our area of interest. Again, the washouts behind the bridge abutments came from the bid is what we determined. The curb walls that you can see in the picture there need to be removed. There needs to be concrete repairs on the abutments, and the rail will need to get relaid, obviously.
So the main objectives for the repair design for Bridge 421 were repairing the concrete abutments, removing the curb walls and replacing them with riprap, and then creating a slope design to fill in the embankments back up to the level of the rail. We're looking at the concrete abutments. They are pile driven and show no evidence of moving or tilting, but we did see cracking and spalling throughout both of the abutments. So the proposed repairs will be surface repairs consisting of chipping and sealing. Performing these repairs will help maintain the strength of the concrete and extend their useful life. And so now addressing the flooding issue and the runoff erosion issue, we were advised by our environmental team to remove the curb walls and replace them with a riprap design. And on the next slide here, this is the riprap design. It goes around each abutment 180 degrees and extends into these eastern ditches. These eastern ditches were determined to be that failure mode of the 2016 flood event. Everywhere that there's riprap, there will be a layer of textile Brooklyn fabric underneath. The riprap sizing used for this design is extra heavy, and that was chosen based on the SAAD standards. So in total, this design will cover roughly 300 square yards, and it does not intrude any further on the river than the existing curb walls do right now.
Looking at the slope design for Bridge 421, we are going to use a 1.5 to 1 slope. That is the minimum required by WSDOT. The riprap, you can see the red lines. That's going to go to the bottom of the steel girder. That is the structural makeup of the bridge. And then for the embankment, that'll go to the top of the rail. That'll also be 1.5 to 1 for the slope.
So for the structural analysis for Bridge 421, we decided to use 3D, which is software that allows you to make a model of the structure based on the individual members, and then apply various loads to it and see how the structure reacts to it. For the model itself, we based it off of the original drawings from CN, along with pictures that we took during our site visit. Then the loads were based on the REMA specification. And once we applied those loads, we ran a unity check for the model to make sure that it conformed with the appropriate code specifications based on number types of steel or future.
All right, so what you're seeing here is just a basic construction cost estimate for Bridge 421. A lot of the costs I have highlighted here. It's the main areas where the track we lay down, a lot of earthwork, clearing and grubbing, and the cost of the abutment repairs. This project came out to be $7,000 estimated.
Moving on to Bridge 421's construction schedule. As mentioned, there are phases with this schedule. The Bridge 421 construction takes place during construction phase 2. It is a total duration of approximately 41 days. And also let it be noted that any permitting that's required for the construction of this project can be done prior to the construction season. We anticipated construction would start this spring for Watco. And also the phasing is done in such a way so the construction is done in a linear fashion away from the Mellon transload yard. So starting with the transload yard and then moving north, hitting the embankment, Bridge 419, and then Bridge 421 would be last, but the construction can be done concurrently if Watco chooses to do so. And as you can see here on the right, these are the core activities we found crucial for the Bridge 421 construction part of this project.
For Bridge 419, the review, Bridge 419 is the one that was washed out because of the culvert failure on Highway 13. You can see in the picture that is some of our group performing a bridge inspection. or our version of a bridge inspection when we did a site visit back in September. The goal for this redesign was to leave as much of the existing structure in place because we thought that it was structurally adequate. For the slope design, looking at the slope that washed out, the goal is basically just to lay a geosynthetic fabric down and then riprap all the way to the top of the rail. We'll use extra heavy riprap again for WSDOT standard for a stream of this size. WSDOT requires 1.5 to 1, like I mentioned in the last bridge, but they recommend a 2 to 1 for when the height of this when the height of the slope is greater than 15 feet. They recommend 2 to 1, so that's why we went this design. This bank was done in Rock Science Slide 2. I'm not going to touch on Rock Science Slide 2 very much because Gabe with our geotechnical group is going to talk about it a lot more. The factor of safety for this slope came up with about 1.1 though.
So here you can see an elevation drawing of our preliminary design for Bridge 419. On the northern approach, we have done a reconstruction design with 3 concrete spans. The the right side of the bridge here is the existing structure. It should be noted these round steel piles are driven to roughly 70 feet. So we have no inclination of structural instability of the existing structure. Should also be noted that for the new construction portion of our design, we referenced Union Pacific 2020 concrete beam bridge standard. And with that standard, we called out 3 30-inch double box beam concrete spans, 26 feet long each. And they are supported by steel H-pile vents, 3 piles each. And we also had to design a concrete riser block that would adapt the shallower concrete spans to the deeper 5-foot steel deck plate girder span that you can see right here. In the upper left here, you can see the typical drawing of the section of the concrete spans that we are using. This is coming from the UP standard as well. We will have a ballasted timber tie track. And in the lower right, you can see the standard precast strand layout for the structural reinforcement of the spans that we are using. And we selected the layout that is sufficient to carry the 26-foot spans of these concrete spans. So here you can see the general layout of the H-pile vents that we are using. To the left of this break line here is the layout for the 3-pile vents, which is what we are referencing. To the right here, that's the 4-pile layout. The sections of these piles used are HP 14 by 89. And it should also be noted that we put we called out the exterior piles to be on a 2-on-12 batter to provide sufficient lateral stability for the structure.
So again, for the structural analysis, we use recent 3D to perform it. This time, we also use the Union Pacific 2020 precast concrete beam bridge design for the new structure off towards the left side there with the concrete spans. Once again, we added the loads to it, random check to make sure that it was all conformant with the appropriate codes or specifications. And although in this case the concrete beams are added in weight and shape to it, analysis was not done through these. They're relying on the Union Pacific 2020 precast concrete beam bridge design for that.
So looking in the cost of Bridge 419, again, there's going to be a large cost for the track. This bridge involved a lot more steel work. That's going to be a large cost again. And our deck panels on the bottom there, another large cost for that. This bridge came out to be at around $310,000, which is much more than 421.
And so moving on to Bridge 419's construction schedule, similar to Bridge 421, it is during construction phase 2. As you can see here, the total duration for this construction is approximately 49 days. And on the right here, you can also see the core elements of construction we found for Bridge 419. And also, just to note again, any permitting for this bridge can be done prior to the construction season beginning, which we anticipate to be next spring. Are there any questions?
So I know this is like very preliminary, like engineering, but what did you guys base the front half of, or the northern side of 419, Bridge 419 off of? Like, did you guys have a prior design that you based that segment off of? Like, has it been done before?
Yeah, so that's when I mentioned the Union Pacific concrete bridge standards, it is basically a book of pre-engineered bridges. You figure out the site conditions of wherever you're planning on using this design, and then there are tables that you select from based on the loads and other conditions, and sort of drop that design in, and that's what we referenced.
Okay.
Got 3 questions. First one is you're using a precast concrete cap on top of the new piling?
Correct, yes. Okay, that is also from the standard.
Yep, that's what I figured. Next one is the thickness of the riprap that you're proposing. What's the depth of that?
It's about 2 feet.
About 2 feet, okay. And the last one is, what did you use to come up with the cost estimate as far as the bridge work goes?
So I reached out to Pete Shirlow, and he went to the name of the supplier escapes me right now, but he went and contacted a supplier that fabricates all of the components of the new bridge, and they came back to us with a quote.
Okay. Thank you.
Any other questions?
What bridge loading did you use?
Like I said, it's the loads were based off of what was in the arena specifications. So I mean, you know, live load, dead load, snow load, wind load, and then various combinations of those.
The live load, what did you use?
Oh, we used E70, Cooper E70.
Any other questions from the audience?
Any other questions?
Oh, something there.
Well, if there are no further questions, we're going to go ahead and take a 5-minute recess then. We will rejoin here at approximately 8:32.
For our audience, there are some refreshments in the back corner here. Donuts, I think there's some coffee there. So help yourself.
I'm in Sam.
right, everyone, we'll go ahead and get started again.
I'm John.
Gabe. Carter again.
I'm Scout.
And then we're with Lake Effect Engineering and Management. We were part of the construction management team, and then these John and Gabe were part of the embankment design repair team.
All right, so this is the site we were tasked with repairing. This is the High Bridge embankment. It's called that because it's located near the small town of High Bridge, Wisconsin, right off of Highway 13. It runs over top of a waterway called Silver Creek. So a little bit about the current site conditions. There used to be a track over top. It was originally a timber rail bridge that had a bunch of backfill dumped over the side to create a big pile of dirt known as an embankment. And that 2016 flood event caused the embankment to become saturated at the top. That increased its overall unit weight and caused a shear failure of the slope, and most of it washed down Silver Creek. So all of the track is gone. The only remnants are those timbers as seen in the figure right here. And portions of the embankment are also gone. But there's also a culvert located at the bottom of the embankment that was actually not damaged. So the site conditions continuing. The soil is approximately a USCS SCSM soil type, which is a clay silty sand. We use that for most of our design calculations and standards. So the main goals of our design for this site were to refill the embankment to the proper dimensions to support a track and then stabilize that fill. So this is the culvert routing Silver Creek. It's a 15-foot tall arch culvert. It's about 300 feet long. It has wing walls on either end. It's mostly intact. There's a little bit of cracking. You can see it up at the top of the arch here in this figure. But other than that, it is in great shape. So the only factor it placed in our design was making sure nothing really interfered with it. So we had to begin our stabilization of the embankment with the top of the embankment. So our client Waco requested that we allow for backfill operations to be conducted with side dumping rail cars. So that meant the top of the embankment and the track had to be placed first. But to do that, it had to be stable. So the first step was placing steel strip piling, represented in blue right here, a certain distance away from the center line of the embankment to ensure that the rail could be placed. So the software that I used to determine where the sheet piling will be placed is called Rock Science Slide 2. Now a little bit more about Rock Science Slide 2. It's a great slope stability software, very user-friendly. It uses what's called the method of slices. It determines all the different failure surfaces based off of slope dimensions, as well as soil data and groundwater data. And it takes little slices of each failure surface, does statics on it to determine resisting forces and pushing forces. It divides the resisting forces by the pushing forces, gives you a safety factor that averages all the slices for each failure surface. And then the minimum safety factor based off of all the failure surfaces on the slope is what's given as the safety factor for the entire slope. So I use this to make sure that the sheet piling will be placed at a proper distance away from the center line and it would not fail. So this was used to determine both the depth of the sheet piling and how far away it was supposed to be placed. So continuing with the stabilizing the top of the embankment, the next step is to add more backfill and then add the track. So for the backfill, we're recommending the same SCSM soil that's present there because that's what we use for our modeling. And the top deck where the track is placed is going to be about right here. We're planning for that to be 28.5 feet wide, 8.5 for the railroad ties, and 10 feet either side for plenty of clearance. And the orange represents the rail ballast. I wanted to make sure that didn't account for any slope stability failures. And it's hard, I know it's a little difficult to see, but this purple here is going to be a little bit of a geogrid to make sure that none of this goes past the sheet piling. So I did another slope stability analysis for this portion of it. And the factor of safety for this top portion is about 3.3. So it's plenty safe for these train traffic for backfill operations. And just in addition, the final grades will match the existing track that has not been washed out. So this is our plan for the full embankment stabilization. The bottom of the slope, also needs to be filled to reflect the new dimensions of the top. But it's severely unstable when it's not assisted by any means. It's a factor of safety of about 0.38, which is extremely unsafe. So to stabilize the bottom of the embankment, we chose to use devices called soil nails. I'll discuss them more later, but soil nails make the soil change from a particulate matter into acting more like a mass. So it's much stronger than it would be without anything. And they're spaced far enough horizontally to allow for vegetation to assist in further stabilization. We're going to use native plants and to help with both butterfly population and by Wisconsin DNR standards. So this slope here with the soil nails has a factor of safety of about 1.2. Now that's also with worst case scenarios and maximum soil nail spacing. So I saturated the entire slope and soil nails are about 40 feet apart. There's just a little bit more about where I got my data for these soil nails. So this detail over here is from a Chinese study on soil nail strength. I thought it was the best possible detail I could find on what these actually are. So you have a borehole that is grouted with a centralizing PVC duct placed in it. And then the soil nails are made out of steel threaded rebar that are placed in the center here. So they're fettered in the hole with the grout and grouted twice. So since it's grouted around the soil and inside the PVC, it doesn't move around and it also won't corrode because it's, steel also has a risk of corrosion. And then up here, there's a bearing plate which keeps it from pulling out. It's also a steel bearing plate. It's usually about 4 inches square. So the data I got came from the Williams Form Engineering Company, Belmont, Michigan. So I used their number 8 rebar, which is 1 inch in diameter, and this has a 75 KSI yield strength. So it's specifically their all thread rebar, which is different from standard rebar because the entire thing is threaded. And so that was what I used for the entire slope design. And I'm going to invite John to discuss the actual design details right now.
So to begin, we're going to start with our profile view. And we're going to work from top to bottom. At the top, this X is going to be the geogrid. This will be put into manufacturer specifications because each manufacturer specifies different things. But this is going to help stabilize the topsoil when the track's on there for the temporary use of getting the trains to the next sites. The squares running along is going to be the sheet piling, which is going to be 15 feet long and it has to be driven 13 feet deep for full capacity of what we analyzed. These small holes are going to be all the soil nails and they're spaced 40 feet apart with vegetation in between running from strawberries to milkweed. And then vertically they're 3 feet just so that we can get all the soil nails in and to make sure the culvert's safe, no soil nails will be touching the culvert. We put that into our design. Now we're going to go to our plan view. This site is located roughly at station 417 based on the track charts that were given to us by our client. The culvert is 300 feet long. And on the north end, we will have to place riprap. We didn't classify the size of riprap because it could change with some erosion and more storms. So that's going to have to be field verified. Once again, our sheet pile is going to be spaced at 50 feet between each other. And then the top bed for the track is going to be 28.5 feet. So the extra slope on there is going to be 1.5 to the sheet piling. Our standard detail for it shows the different lengths of soil nails that we're going to be using. It ranges from 10 to 50 feet. The slope past the sheet piling is going to be 1 to 2 to help. It has to be a minimum of 1 to 1.5. So we're going to use 1 to 2 for variance. And as it shows here, this is going to be the top of the culvert. No, none of these are touching. And it's also underneath the sheet piling.
So looking into the cost estimate for the embankment, there's a large quantity of material fill that will be needed. Another high cost I have highlighted as the driven piles and our soil nails. This project came out to be the most expensive at about 2.45 million.
And so moving on to the embankment construction schedule, there are actually two parts to the embankment construction schedule. As mentioned previously, there are phases within the construction. So part one of the embankment will take place during construction phase 2. Is actually the first part of construction phase 2 and is the closest to the melon transload yard. The total duration is approximately 30 days for the fill of the material. And the reason we broke the embankment up into two parts is we want to get the embankment up and running as quickly as possible for Watco to begin using that line. And then any long-term soil stabilization will come after. As you can see here, we have a temporary erosion control measure in place for any short-term erosion problems like storm that might wash out while the construction is taking place. So moving on to part 2 of the embankment, this is during construction phase 3, and this is the long-term stabilization of the soil at the embankment area. This is to prevent any long-term issues as far as washouts go. That is a total duration of approximately 42 days. And as you can see here, this includes the riprap, adding riprap, soil nails, and planting vegetation on the slope to help stabilize it further from any potential washouts. Are there any questions?
Have you identified any locations in the area for borrow to get the fill from if it's necessary?
We have not. Okay, we have not identified any locations.
How tall is the embankment?
80 feet.
Factor of safety that you were talking about, what's an appropriate factor of safety for slide slopes like that?
Well, honestly, you're not gonna get a much better factor of safety on most of those than 1.2, so that's about what we have. But I mean, ideally, we'd like to get it up to 1.5. But considering I wasn't able to model it with the plants and also with you know, minimum soil nail spacing and also with the full saturation, I was only able to get it to about 1.2.
The toe of the slopes will land approximately where the last toe of slopes were,
Approximately, yes.
everything inside the right of way?
Yes.
Okay, thank you.
Okay, thank you. We will move on to our transload yard area then.
I have a question on Zoom.
Go ahead.
Yeah, I'm just curious, do you know, is your slope design similar to what was done at Mont Ripley?
I do not know what exactly was done at Mont Ripley, so I cannot really tell you if it's anything like that.
Okay, I know they did the soil nailing too. I was just wondering if there was some other similarities, but
Yeah,
nice job.
our project was in Wisconsin. I actually did some research and I found there was a similar project in, I believe it was Madison. I don't remember the city exactly, but that's one of the, there was a specification for that project I used to help me out.
Okay, thanks.
Cool.
I had one question. I'm not familiar with the site, so maybe that would help a little bit. Is the site only accessible by rail? I guess I'm just curious if there was some point where looking at what had to be done to haul in by rail, that if maybe there was a conversation with the railroad to say there's a different way to bring fill in.
It is mostly accessible by rail. The reason it would take a lot more effort to get anything in by truck, and also the rail cars can carry a significantly larger amount of fill material than any truck. So that was, and it's also much cheaper to do it that way as well.
Okay, yeah, I was curious when the cost differential between the hauling by rail versus hauling by truck compared to if we could have avoided all the other soil nails, etc. If we just didn't have to worry about having that in place to get the train cars in there initially.
Yeah.
That's all.
Well, good morning, everybody. We are DGN Associates. My name is Christian.
I'm Ethan. I'm Jonathan.
I'm Justin. And we were tasked with designing a transload facility for materials for Watco.
So a transload yard is a site where commodities are transferred from truck to rail or rail to truck. It allows a shipper to best utilize the efficiencies of both modes. The transload yard will be the first portion of the overall project to be constructed, and it will provide a source of revenue for Watco to fund the bridges and the embankment. And it will enable area businesses to once again use rail to ship their products, because they haven't been able to since 2016 when the flood happened. So here are a few commodities that will be shipped out of this yard, with pulpwood being the highest volume. Here also are a few of the types of cars that these commodities will be shipped on. And here's some design considerations and constraints that we had considered when designing this yard. The biggest one was limited space, especially when taking into account truck movements throughout the site and how to load these rail cars. The existing infrastructure, where can we build new rail, or where can we put our truck entrance in relation to the highways and the rail that's already there. Storage, some of the commodities need to be stored inside, some outside, some of our more storage space than others. Take that into consideration. Of course, the commodities to be shipped, the types of rail cars, and how to load them.
So another design constraint that we had to, or that we worked with, was the Wisconsin Department of Transportation Highway Maintenance and Rehabilitation Project on Highway 13. And this is set to start, I believe, next year. And part of this project will consist of widening Highway 13 adjacent to the proposed transload yard, restoring the grade crossings to the proposed transload yard, and adjusting the active warning signals on Highway 13. And this is all worth noting because when we went to our site visit, we discussed with our client that the Wisconsin Department of Transportation would be funding most of these improvements, so therefore it'd be very little to no cost for our client. So our client had some specific requests for us when it came to designing the site. First and foremost is to not add any additional highway grade crossings over Highway 13. Highway grade crossings are very, very expensive, and if there's no need to add more, then there's no need to pay for more. The second request from our client was to have trucks enter from Highway 13. As I mentioned, WisDOT plans on widening Highway 13 at this location, so it should make it easier for trucks to enter the site. And lastly, our client requested that we keep the Y on the site. Another aspect of our project was to make sure that the employees that will be working at the transfer yard will have parking areas. So when we went to our site visit, we discussed with our client potential parking setup, and we determined there was no need to add any additional parking facilities, as there's a asphalt pad located right in front of the depot, and this will save on project costs for the client. So now on our first part of our recommended design, we recommend to our client that they adjust track C, they add track D and track E to the site, and we'll get into those in the following slides. And the associated site work to go with this part of the construction, add a diesel tank to support the equipment on site, to add a storage building, which I'll get into a little bit on the next slide, and to move the existing signal box that's on site. Currently, the signal box is located in the driveway where trucks would enter the site, so we decided to move this signal box to the other side of Highway 13 to avoid any potential collisions. And then the estimated cost for part one is about $1.5 million. So the track C adjustment, if you were to go to the mountain site today, you would find that track C is there. However, we recommend to our client that they adjust this track, and the reason for this is to fit track F in part 2 of our recommended design, which we'll get into here in a little bit. This adjustment still allows the site to act as a Y, and that was a major design requirement for us. Now on the track D, this is our main loading line for the site. Originally, when we went to go design this, we actually thought about doing the loading on track A, otherwise known as the main line. However, we were advised that this was not a good idea because of the location of track A to the Highway 13 grade crossing. It would require during the duration of the loading process that the warning signal arms would have to be activated during this entire process. And this was simply not an option because Highway 13 is not only the main street for the town of Mellon, but it is also a major route for the Ashland area. So then to combat this, we decided to design a stub track, and this stub track can accommodate up to 10 cars at a time. And the end of the stub is located about 65 feet off the center line of track A, which is worth noting because as Justin mentioned, center beam rail cars will be utilizing this site. Now on the track E, So as I mentioned in track E, they can only accommodate about 10 cars at a time. So if you have like a train that's 15 cars long, you're gonna need an area to break them off. So we decided to design another stub track for this, and this track E can accommodate up to 9 rail cars at a time, and is located about 20 feet. It is located 25 feet off of track A. I'll turn it over to Christian to go over part 2.
And as he had stated, this design was two parts. One was just to mainly get it up and running so Watco can start making revenue off it and get it open. And then part 2 is later on down the road for future clients. So is to construct an indoor loading facility, which you can see in the purple here. This, I'll get into that in a little bit. There's still room for storage to the north of the building. It'll support approximately 25 to 30 cars. That was roughly what it was way back in the day, and that's about what we can manage with the constraints. The total cost is about $850,000. So track M is 800 feet in length. It'll hold about 9 to 10 cars a day. We need to add a number 10 turnout to the site and then connect a number 8 on the south side of the track. This goes through the loading facility. So materials that need to be housed indoor can be unloaded in there. So the indoor loading facility is 112 by 125 feet. This gives enough room for a medium-sized wheel loader to be used within it for moving materials from truck and to truck from train. There will be a truck entrance to the north end of the site. Trucks will have to drive in or back in. We weren't able to get it to go through and through, but the trains are allowed to go through and through. We're recommending they have roll-up doors for the track and train entrances, keep everything closed up. And then the eastern building edge is 15-foot clearance from the internal loading facility. There's dedicated storage area even with the facility. You can hold a lot of logs, as pulpwood's going to be one of the main products there. And there's 25 by 25 squares for storage, just to show different area products.
And for the truck entrances, trucks will enter on Highway 13 between the grade crossings. And as mentioned before, the existing signal box will be moved northwest of the grade crossing, which is actually across the road. And for site maneuverability, we use the AutoCAD SWOT path analysis software. We went through both parts of the project to ensure that the project was practical and that truck could maneuver without running into any materials. There's plenty of room for storage materials in both parts with the truck moving around, and the design vehicles were a Pettibone 204i carry lift and a WB65 tractor truck and trailer. And even with the indoor loading facility in part 2, there's plenty of room for material handling outside and inside the building. And we may want to extend some on-site grade crossings since the entry from State Trunk Highway 77 is constricted and the trucks may run over the rail. Then, according to our chief consulting, the proposed transload site is at risk in the event of a 1,000-year storm. In the case of such an event, we'll have sandbags and an emergency shut off for the electrical outside of the depot. Then for recommendations, we recommend that this is a 2-part project. 1 part to get up and running and 1 to handle the commodity that goes in the loading facility. We'd also like to have a structural analysis on the battery of the rail bridge prior to the site opening, just to make sure it's structurally sound. When we were at the site, we didn't see any problems with it, but we didn't take too many observations. And the indoor loading facility should have roll-up doors for the truck and the train entrances.
So looking into the cost estimate for this transload yard, one of the main costs is going to be our track again. This had the largest quantity of track throughout all the projects. Our PFAT building is going to be put up, and our turnouts. This project came out to be about 2.35 million. It was like the second highest project in the area.
So moving on to the transload yard schedule, there are 2 phases as mentioned for the transload yard. The first phase of the transload yard will take place during construction phase 1. And once again, this is to get the site up and running as quickly as possible for Watco. And this involves mainly getting the track down so any train activity can begin taking place in the melon yard, as well as any potential storage area for materials for the embankment or bridge construction, that goes beyond that. So and as you can see here, the total duration for this phase one, during construction phase one, is approximately 37 days of construction for the transload yard. For the transload yard phase two, which is found in construction phase four, has to do with the prefabricated storage building for the transload yard. This is to house any storage, any material that needs to be stored indoors. And we felt that having this construction take place after would be more efficient in getting the transload yard up and running as quickly as possible. Are there any questions?
How many trucks do you guys predict to be able to go into the loading zone? Because that turnaround just looks very tight to me. I know it's definitely possible. I don't know how many trucks it can hold up.
Yeah, in situations like once the indoor loading facility, which is we assume to be way down the road, probably about 4 or 5, but as you can see, like early on, there you can house like 8 to 10 trucks.
If it was decided to bring embankment fill in by truck, load in Mellon to take up to Bridge 417, culvert 417, what track would you suggest is used for that operation?
Well, like in, since the embankment would be happening early on in the project, we could use either the like Y track, so that'd be track C or track B, because all that area is not going to be utilized, so you could potentially put some fill there.
There's a question back. Yep. Yep.
Right. Is it an above ground diesel tank or below ground diesel tank?
Above.
Have you considered the risks for if it could get hit, or since it's so close to the parking lot, if there's any protection for it?
The depot it's right on the side of the depot. There won't be any well, we're gonna put
Bollards up.
Yeah.
Questions on Zoom?
So just to be clear, Brad Piet here. In the transload yard, you're keeping the north leg of the Y, and there'd be another additional track to go through the building that would also connect in.
Yes.
Okay, all right.
Any more questions on Zoom or in person?
It looks like there's a curve inside the building. When you have that installed, is that going to be true?
Yes.
Or is it a straight line through there?
No, it's curved. It seemed that it would be okay. We never felt that we'd run into any issues.
When you're doing the log loading for the lumber activities, or the log scope, in relation to the tracks that you had there, what track you would be using for that?
That would be track D. And we show that kind of in the storage area too, but the storage area, that just showed the storage area for part 2 of our design, but in part 1, it's the same area. It's right off of track D.
There's just more area with the
How does that Y work for turning around trains?
Yeah, so then so if trains are coming from Ashland, basically the idea is so if they're coming in from Ashland and going back to Ashland, like one way that they could potentially take is that they come in from Ashland and then they cross Highway 13, then they continue on and they back up on the Y, and then so that would be they go from track A to track B.
You put the picture up?
Yeah, that would actually be easier. Overview. All right, so then most of our traffic we plan is coming from the south. So then I guess I'll just start with that. So then if they're coming from the south and have to go back south, we would recommend to them if they need to unload here in track D, that they would come in and they would back up on the track D. Then if they need to break off, they can pull forward and go break off on track E, pull forward, go back to track D. And then when they go to leave, they can continue forward on track A all the way up there and then back up on the track C. And then once they get fully off, they can continue forward going back down south. And it'd be a similar movement if trains are going to Ashland too, so.
Is there no space to the south to make that operation work?
Yeah, so then that's why we recommend that they perform a structural analysis on the Bad River Rail Bridge, because it is
like all the train maneuvers are likely gonna have to utilize that bridge in some way, and that's why we recommended that they should get a structural analysis.
Great, we'll turn it over to our environmental permitting and construction routes.
All right, hello again. My name is Annabelle and I'm with RQ Consulting, and I'm going to go over the environmental permits that will be required now that we've heard all of our designs. Starting with the wetland considerations, we use the Wisconsin Department of Natural Resources, or WDNR's surface water data viewer, and they have cataloged mapped wetlands as well as wetland soil indicators. So we used it and we worked with our other companies during the design phase to make sure we could completely avoid any of the mapped wetlands within that database, and we minimally overlapped those wetland soil indicators. And in tune to this, we're going to have a professional wetland delineation done either by the WDNR or an insured delineator by the state of Wisconsin. And we got an approximate estimation of this cost from the WDNR in this range here. And for our approximate total 16 acres of impact across the 4 site locations, that'll come out to about $1,400. Estimating the cost of the environmental permitting, we approximated about 6 hours per permit application and at a rate of about $85 per hour for an environmental engineer to do this work. So in total, all the environmental permitting costs for the permit fees, the work cost, and the wetland delineation will be about $18,000. So starting at our northernmost site, Bridge 421, spanning Brunsweiler River, you can see our area of impact at about 0.57 acres. And shaded in purple there is the wetland soil indicators. So there's no mapped wetlands near this site, and we can avoid those completely. The state of Wisconsin has different levels of permitting, starting with federal, state, local, town, local, and city local. So all 4 of our project sites fall in the St. Paul Regulatory District. Starting at the federal level, Bridge 421 will require a transportation regional general permit, category 2, modification of linear transportation. This permit will trigger a federal nexus with an ESA Section 7 consultation from the U.S. Fish and Wildlife Service. On the state level, it's important to note that Brunsweiler River is a wild river and an area of special natural resource interest. This will impact those state level permits and will need an individual permit rather than a general permit. So because Bridge 421 is a clear span bridge over Brunsweiler River, we're going to need this waterway and wetland permit from the WDNR. We also have that riprap design we talked about previously, so we'll need a stream bank erosion control permit. These 2 WDNR permits will trigger a consultation from the State Historic Preservation Office, or SHPO. We'll also be needing an endangered resources review from the state of Wisconsin. So this is our total permit matrix. So local, town level, and Ashland County, Brunsweiler River has a regulated floodplain by FEMA. And because of that, we are changing the cross-sectional area under the bridge. We don't expect the regulated flood height to increase, maybe decrease because we're expanding that area, but we need to have a land use permit from Ashland County and coordinate with their local zoning ordinance. So moving south to Bridge 419, spanning Trout Brook, you can see our area of impact here. We've included some laydown area materials as well as that construction access and the direct construction activities. We have some minimal overlap with some wetland soil indicators. We'll find out with that wetland delineation if we'll need any further permitting, and we're avoiding this yellow mapped wetland. The total area of impact is 1.81 acres for the site. So once again, on the federal level, we'll need that same transportation regional general permit, which will trigger that federal nexus with the U.S. Fish and Wildlife Service. On the state level, Trout Brook is also an area of special natural resource interest and a trout water. So when we're getting those permits, we need individual permits rather than general permits. We'll need an individual permit, waterway and wetland bridge from the WDNR. And because the area of impact is greater than 1 acre, we're going to need a construction site stormwater runoff general permit. We also have a riprap design for this site, so we'll need a stream bank erosion control from WDNR. These WDNR permits are going to trigger that SHPO consultation again. We're also going to need that endangered resources review. Moving south again to our high bridge embankment, the construction site access was included just to be conservative on our area of impact estimation. You can see Silver Creek here. We do have some overlap once again with those wetland soil indicators, but that's okay. We'll find out in our wetland delineation if we need anything else happening, and there's no overlap with the mapped wetlands.
The total area of impact is 7.06 acres. Once again, the same federal level permits required, causing that federal nexus. At the state level, it's important to note that Silver Creek is also an area of special natural resource interest and a trout water. We talked previously about that riprap that's going to go directly into the stream. Because that's not on the stream bank, we're going to have that fall under miscellaneous structures. It's going to be a little more impactful, so that's why it's an individual permit. And we're also going to need a construction site stormwater runoff general permit because the area of impact is greater than an acre. These two WDNR permits are going to trigger that SHPO consultation once again, and we're going to need that endangered resources review. And just like Runtweiler River, Silver Creek also has a regulated floodplain by FEMA, and we're putting that riprap into the stream. So that may change the flood height. Once again, we don't expect that to increase significantly, but we'll need to get a land use permit from Ashland County and talk with the zoning ordinance and make sure that's all okay. And lastly, we have our proposed Mellon transload site. You can see just a little bit of wetland soil indicator in a map wetland, but we're not overlapping with any of them. And our area of impact is estimated to be 6.44 acres. There are no federal permits at this site, but our area of impact is greater than 1 acre. So we're going to need that construction site stormwater runoff general permit. That's triggering the SHPO consultation, and we'll need the endangered resources review. So lastly, we'll talk a little bit about some threatened and endangered species that can be found in Ashland County and specifically maybe at our sites, starting with the Canada lynx and the gray wolf. Because they're larger mammals, we're not going to have to do any special considerations for them in construction. We'll assume that a loud construction noise will scare them off and we will hurt them. Moving on to the northern long-eared bat, endangered species. The state of Wisconsin has the most stringent requirements for this species. So we're going to have an avoidance time from June 1st to July 31st. The state of Wisconsin would prefer extending that to August 15th. So keep that in mind. And we also can't have any tree removal within 150 feet of a known roost tree. We don't expect any significant tree clearing, but keep that in mind during construction activities. The piping plover is a coastal bird, and because Ashland County lies on the coastal Lake Superior, this is coming up, but we don't expect to find this species at any of our sites. And lastly, the monarch butterfly is a candidate species. We are going to be using milkweed at the High Bridge embankment, which has great taproot system for soil stabilization and can also enhance their habitat.
So moving on to construction road access and working with our environmental team. So for the construction road access for Bridge 421, we anticipate using the existing Ensinger Road here that runs parallel to the existing rail track. There is a northwest and a southeast entrance of this road. The southeast entrance is preferred as it does not go through any residential areas and is the closest to the town of Mellon where material might be stored. The bridge that is for vehicle traffic that runs on Ensinger Road here has an estimated weight capacity of approximately 7 tons. So an issue might come up there with any heavy equipment that might be wanted to cross that bridge, but there's not really an issue as there is an entrance from both sides of the road. So depending on the side of the bridge they want to work on, crossing the bridge won't even be necessary, just more of a logistical challenge. Also worth noting is WACO should consult with the state of Wisconsin if they can plan to do construction in the spring for any weight restrictions on dirt roads, depending on how saturated the road is. There's usually weight restrictions, so the road doesn't get messed up. The yellow area here is potential laydown areas that would require just some basic clearing and grubbing for storage of materials on the site, as well as staging any heavy equipments like cranes or anything for the abutment repairs on Bridge 421. Moving on to Bridge 419's construction access, we plan on using the existing right-of-way for the rail that comes off of State Highway 13, as you can see here. There's enough space on both sides of the rail for some basic clearing and grubbing again for vehicle traffic. And as you can see here, the yellow square once again represents potential staging area for heavy equipment or storage of materials. And then lastly, for the embankment construction access, as I previously mentioned, the embankment is going to be backfilled via rail. So simply rail coming in from the town of Mellon will be sufficient enough to backfill that area. And similarly to the other two sites, there's enough space on the right of way to facilitate any vehicle traffic that might be necessary to get to the embankment area.
So kind of trying to wrap the whole cost aspect of this project up. As you can see here, we got all the costs for each 4 project locations. And this project came up to about a total of $5,300,000.
And then lastly, wrapping up the schedule, because it's kind of complicated with all the phasing we have going on. So the transload yard phase 1 taking place in the very beginning of the project has a total duration of approximately 37 days. Transload yard phase 2, that's our storage building to materials indoors if needed. That is a total duration of approximately 13 days. The embankment part one, which is backfilling essentially, is a total duration of approximately 30 days. And then embankment part two, which has to do with our long-term stabilization, soil nails, planting vegetation, et cetera. Total duration of approximately 42 days, with a large chunk of that time coming with installing the soil nails. The Bridge 419 and Bridge 421 constructions, which are during construction phase two, are 49 days and 41 days respectively anticipated. So, are there any questions?
Any tribal interactions on any of those project sites?
The Bad River Reservation is just to the north, but all the project sites lie just outside of it.
Did you anticipate any significant environmental issues?
Not at this point, no.
Your construction phasing looked like you were doing consecutive projects working from the south to the north.
Correct, yes.
Could this be done concurrently?
Yes, they can be done concurrently if Walker chooses to do so, yes.
Any historical contamination, hazardous material issues associated with any of those sites? The yard perhaps in particular?
Are there any questions on Zoom? Okay, well, that is the end of our presentation. If there are no further questions, thank you for being with us today. We appreciate your time. So thank you very much. Thank you.
Okay.
We're gonna take a break or not?
Yeah. So we're ahead of schedule. Why don't we resume in, let's say at 9:45, because we have some people calling in.